Good afternoon. How's everyone today? Good. Awesome. We are going to take a look at 11.6, section 11.6, which is the last of 11. We'll get into 12. After this, we're going to be focusing primarily on applications. So this is kind of, I don't know, that we'll pick up a new skill today. The place where we'll apply what we learn on implicit differentiation is over here on related rates. So related rates is basically what we're doing today, or the skill part of what we do. When we get to related rates, we will apply what we're doing. Okay? So, I have a question for you first, though. Why are we here? Why are you here? To learn. To learn what? What's the value of learning math? Let me put that. Have you ever thought of that? I think of it all the time and I don't have a good answer, right? Hopefully, as we go through this, it's not about necessarily the specific skills you're going to learn, because I'll be honest with you, we don't know what specific math you need to learn to help you in your career. We know some general stuff, so the general stuff is here. Hopefully, you're learning how to focus and concentrate mentally, and I think that's what one of the best things that math can teach you, is you start to see patterns and you start to see things through. Regardless of how you've done, and I'll get into the exam, I will have those over the weekend. I guess it's some good news what the coordinators decided to do. Your test score will be out of 95 points instead of 100. So that means if you scored 95, you have 100%. If you scored 100%, you'll have over 100%. But anyway, so it's like 5 points. They knocked it down. So that'll be good. Since I have one course for both classes, I need to finish the grading for everybody before I can start posting things. So my goal is to get that done by Friday. And again, when I post it in Canvas, I will also post a scan of your test. Okay, so you can you'll be able to review and see how you did right from there. But as you study, what I'm going to ask you to do is when you start, and maybe when you come to a class, take a moment to take a deep breath. It'll transition you from whatever you were doing before into what you're going to focus your intentions on after that. And I bet you just do that one thing. Take a deep breath, and then start into the next thing. You take a meal. Maybe you say a family prayer. Actually, we did that this weekend. I haven't done that in a while. But if you just, or you thank someone who gave you the food, whatever you're going to do, whenever you transition, if you just take a moment, pause, and then think about what you're doing. What you'll do is you'll get the best benefit, because that's really what we're helping you to learn is some concentration skills, some problem-solving skills. But again, what we're going to talk about today, I don't know that you will ever use this anywhere outside of this class, but the skill of learning to focus and learn, as you said, you're here to learn. You're learning how to learn, and that's what's going to help you. The other part is what we're going to do is we're going to open up the homework, and we'll work through a few problems together. You'll get very similar problems, but this topic is more about algebra than it is about calculus. We're going to take a derivative, but the hard part is we're going to have to do some algebra to get it in the proper form that they're looking for, and that'll probably be the area that's the most difficult. So, last of the skills, right? A lot of applications. Remember, somewhere in here there's 12.6, which I'll do a posted lecture. That's extra credit. So 12.6 I'm going to have as counted as extra credit, which means you can get some extra points if you do it. If you don't do it, it won't matter. It won't affect your grade. And then we've got our exam Monday, looks like October 23rd. Okay. implicit differentiation. What I want to show you is that this is nothing new. It's just what we're going to get up. What we're going to do is we're going to use a symbol to differentiate something here. So let me see if I can get this open. Go back. There we go. So if I gave you this function, and I asked you to take the derivative, could you do that? Sure, no problem. So what we're going to do today is we're going to sort of use the different notation. We're not going to use it as y prime. We could, how we've been doing it, but we're going to use this side is the derivative of y with respect to x. On the other side, we just take the derivative, right? 2 times 2 is 4, x to the first power, plus derivative of 4x is just 4, and derivative of 6 is 0. So is that okay? You feel comfortable with that? Yeah, maybe? Okay. That's all we're going to do today, except there's going to be more than one y. Okay, that's what I want you to say. It's what we've been doing as far as taking the derivative, no big deal. But we're going to have multiple y's, so we're going to have multiple dy dx's, and then we're going to have to solve, so that's algebra, for dy dx on the one side. So that's the harder part, but taking a derivative is not going to be any more complicated than what we've been doing. Okay, yeah, we'll get some logs and maybe some exponentials in there, but it's going to give us practice in taking a derivative, okay? And it's not anything particularly new. So where this comes in is we may have some kind of a expression like y to the fifth plus y plus x. That really, it's got two derivatives. It's got two variables in there, right? It's got an x and a y, and it's got two different y statements in there, two different y terms. So you can't solve this just for y equals. Not very. I don't think it. Sometimes we can't, but it is a function, and it might be something we're needed. So for this particular one, we're going to do something called implicit differentiation. So it's an implicit function because it basically can't be solved for y equals. Looks like this. Let me just kind of show you how we're going to take its derivative, and I'll just put it out there in words. We got another page to do it. But whenever we take the derivative of y, that's the derivative of y with respect to x, just like we did on that first page I did. So when I take the derivative of y to the fifth, what am I going to get? 5y to the fourth, right? I'm taking the derivative of y. The exponent comes down, I subtract 1 from it. May feel a little different because it's a y instead of an x, but what I do is because it's not an x, it's a y instead of an x, I put what I call a marker. This is dy with respect to x. Okay, so we're going to do that. That's that term. The next term, y, when I take its derivative, what am I going to get? What's the derivative of y to the first power? Not 0. 1, right? The 1 comes down, multiplies, it becomes y to the 0, which is 1. I'm going to write it as 1, but what did we just do? We took a derivative of y with respect to x. So we're saying that x is still the input variable. That's what that really means. So we have another dy dx. Then we come to x, right? Plus x. So let's take its derivative. Again, we're just going term by term like we've done before. It's looking a little different, maybe a little messy. What's the derivative of x? X to the first power. The 1 comes down, subtract 1 from x to the 0. It's also 1. What did we take the derivative of? We took the derivative of x with respect to x. So I'm going to introduce this little symbol, which we'll stop using pretty quickly, the derivative of x with respect to x. What do you think dx over dx equal? Good, it's 1. So that's why we won't write it a lot, but I want to show you that, and we haven't written it in the past, but that's really what we've been doing when we take the derivative of x. So all that's really new today is we've got these sort of markers, dy dx and dx dx, that indicate which variable we took the derivative of. And we're going to need it because we're going to get some where we'll be using the product rule. We've got x times y or something. So it does, while I say it's nothing completely new, it's there. But we're not quite done. What's on the other side? It's equal to 0. What's the derivative of 0? It's still 0. Even if it was 5, any number, you take its derivative, it's 0. Okay? So this is equal to 0. And what we're going to do today, maybe not on this one, well, why not? Is we're going to see that we want the final answer has to be dy dx equals whatever. And so the goal is we're going to get dy dx by itself on one side and everything else to the other side. Okay? That's the harder part. It's all algebra after this, right? This is the derivative. Okay? But we want to get the derivative in a form that's dy dx equals. What's something you think we would do with dy dx? Algebraically, yes. Factoring. And you just love factoring, right? No, nobody likes factoring. Not even the math teacher likes factoring. But we're going to factor it out just like if you had 3x plus 3y, you could write that as 3 times x plus y, right? So you factored out the 3. In this case, we're going to factor out the dy dx. So I keep looking for space because this was supposed to be just an introduction, but it's 5y to the 4th plus 1, right? So I factored this and this together. The dy dx comes out on the back side. And again, that's what sort of feels unnatural because usually we're distributing, right? That's how we simplify. Looks like we're not simplifying, but it's what we're doing. Notice we now have only one dy dx. We're not quite finished yet. We still have what? We still have this plus 1, and we still have that equal to 0. I stopped writing the dy dx because that's 1. Okay, so it's just to show you that we always, when we take the derivative, we get something. And then now what do I need to do to solve for dy dx? Subtract 1 from both sides? Good. And so we've got 5y to the 4th plus 1 dy dx equals -1. And now one last step and we're done. What are we going to do? Divide by the stuff in front, right? So we divide by 5y to the 4th plus 1 on both sides. And in the end, it's left with dy dx. It's going to be equal to -1 divided by 5y to the 4th plus 1. We're done now. Does that seem doable? Okay, so derivatives are just like we've been doing, so we're going to take the derivatives. It will get a little bit seemingly complicated, so that's why I'm going to go into the homework. This is being recorded. I finally got all my little gadgets in the same place, so you can go back and look as you go through the homework. Your homework will be slightly different than what we've got, but it'll be very similar. So you'll be able to kind of go back and say, oh, we did it in a lecture, let me review it. Try it on your own, try it with help, however you go through, but just a little bit of practice. Again, we're going to get more practice of this when we get to the 12.5, which is related rates, and that's really what it is that we've got two variables that are related. And this dy dx is really a slope, right, of two different variables, how two variables are changing in relation to each other. Okay. So the technique we're using, or that I've used, this may not be in the book because it's just sort of dx whenever we take the derivative of x. And again, if you don't want to use that, that's fine. You just say, okay, I took the derivative of x, but you'll see how that helps. Whenever we take the derivative of something with a y variable, we will use dy dx as a marker. And then the last step is to do a bunch of algebra to get everything off to the other side and dy dx by itself. And it's going to involve that step of factoring most times and subtracting, dividing, all that algebra step. For the rest of the examples, let's just go into the homework. I mean, that's the lesson. Now we just work some examples, but it's because again, it's nothing new, but it will help us with both the product rule, the quotient rule, and the chain rule that's going to come up. Oh, that's right. It needs that one. Email. So we're doing 11.6. We're going to view that. Want to start off with a simple one or a complicated one? Okay. That was quick. Okay, so we'll start off with number 1. And then we'll do number 2, which is the more complicated one. Okay. So we're being asked to use implicit derivatives to find dy dx. This is what we're given. So I'm going to write it up here. Okay, and just think what we're doing is we're taking the derivative of each of the terms. Whenever there's a y, we take its derivative just as if it was an x, but we put dy dx. We take the derivative of x, we put dx dx, which is 1, so we could do it. So what's the derivative of 2x squared? 4x to the 1, or just 4x. Perfect. Now we don't have to put the dx, but I will, just to say, hey, I took this derivative. It's dx dx. Okay. That's done. First term. We come to the minus y squared. We need to take its derivative. What's the derivative of y squared? 2y to the first, because 2 comes down, subtract 1 from the exponent, and what do we put next to it? Dy dx. derivative of y with respect to x. I don't really know what with respect to x means. It just means x is the input. We're respecting x. It's the main input. Okay? And then we keep going across the equal sign and we take the derivative of 6. 6 is a constant. When you take a derivative of a constant, it's 0. And since no variable was involved, we don't even have to put a marker or anything. It's just 0. Now what do we want to do? We want to solve for dy dx. Okay, so the calculus part is over. The rest of this is all algebra. Okay, first thing, dx is 1, so I'll just say that's 1. Oh, this is just 4x, so let's get it to the other side. That gets us minus 2y dy dx equals negative 4x. We got one more step, and what's that? Divide by negative 2y. So it's not this one. You asked for simple. I don't think we could do any. So we get that. Oops, what happened? Oh, I see. Let me stretch this down. So our final answer, this cancels dy dx. We can simplify a little bit. Negative divided by negative is positive. 4 divided by 2 is going to leave a 2 in the numerator, x, and a y in the denominator. And that's our answer. Again, what you'll have is the red letters, the red numbers are what will be different in yours. So it'll be some x squared. So again, you may get something a little different, but as far as the complexity, that's it. Okay, so a little bit of practice. Again, you may want to go into the ebook and pull up some additional ones because we're, we got it done. Oh, the homework's done. We don't need to do it now. But maybe, for practice. Is that, so far the process is okay? Not too bad? Let's kick it up a notch, as Emerald would say. Okay. So again, we'll copy this over here. We've got a x squared y, x squared times y, minus y squared equals 3. So what do you notice about that first term? Which of our special derivative processes are we going to need to use? The product rule, right? We are multiplying. So we're going to need to use the product rule. And when you're using the product rule, since we've got two variables, it's kind of, well, which one do we start with? What you do is you treat one as a variable and the other as a constant multiplier. And then you switch it and you do the other. So let me see if we can do it in a meaningful way as we go through here. So let's go ahead, since x squared is first, let's take its derivative first, and we'll just treat y as if it's a number. So what's the derivative of x squared? 2x. Again, we could do the dx, but that we're going to cancel that anyway, so this is the place where it just becomes, I'm just not going to put it there. When I take the derivative of x, I don't need to put anything. Okay? And then y, it's times y, because y was a constant. I'm treating it as a constant multiplier, so it just tags along for the ride. Product rule says then we add, we're now going to treat y as the variable and x squared as a constant multiplier, right? So what's the derivative of y? 1 times x squared, because that's a constant multiplier. Since we took the derivative of y, we put dy dx. Okay, so you see how that's the only new thing. we've got this marker here. So the marker that we took a derivative of y. We okay so far? I mean, that's the product rule, right? You basically take the derivative of each of them. And when you're taking the derivative of x, you treat y as a constant. And you take the derivative of y, you treat x as a constant. So it just multiplies. Then we've got this term here, y squared. When we take its derivative, what do we get? Minus 2y to the first power. Since we took the derivative of y, we need dy dx. Okay. We got our equal sign. What's the derivative of 3? 0. So you see, it doesn't matter what it's equal to. It's always going to be, the derivative is always going to be 0. Questions? We okay? Yes, sir.
So the y on the first part of it doesn't disappear because it's constant?
Yes, it's like it would have been like 3x squared, right? That 3 is still multiplying.
Okay. What's the like plus and then the 1 times?
It's 1 times x squared. So on the second part, when we're taking the derivative of y, the 1 is the derivative of y. X squared is now like a constant.
Oh, so you have to do it twice?
Yeah, product rule. Remember,
Okay.
derivative of the first times the second unchanged. Derivative of the second times the first unchanged. Yes. This is where the product rule will maybe start sinking in. That's kind of where it made more sense to me, because you got to use it. But it's also, you might be tempted, let's just take the derivative of the first one and leave the other one alone. You'll be missing a term. Okay, so you got to follow through with the product rule. Yes.
Wait, so for the second part that you're talking about, how come x's second stayed the same instead of becoming like 2x?
Because we didn't take its derivative. We took its derivative on the first part. So derivative times the second one unchanged. This is where x squared just carries on as unchanged.
Okay, so it's always the first one you're taking the derivative of?
Yeah.
Okay.
Take the first one times the second unchanged, and then you take the derivative of the second with the first one unchanged. Good. Okay, so this is, like I said, yeah. This is going to make whatever we did on that first test much more understandable if there was any misunderstandings, and that's why, and that will show up on the final. You'll do better, and I'll be able to. Not yet. Okay. Just keep going. Final answer, we know we'll get to the final answer when we have 1 dy dx equals all the other stuff. Okay? So, how do we want to do this? I'd like to, so we want dy dx by itself.
Where did the x squared, 1 times x squared come from?
The 1 came from the derivative of the y, and x squared came along. So it's the product rule. Remember the product rule, if you have a first times a second function, you take the derivative of the first times the second unchanged plus the first times the derivative of the second. I switched the order of what I did the derivatives in. But that second term, this 1 comes from the y, the derivative of y is 1, dy dx, and then x squared is just, it stays the same. So whenever you got a product rule, you're going to get 2 new terms, right? There's always going to be that plus. That's how you know you did the product rule. Okay. We okay? Because this is, again, I don't want to lose anyone as we go because it's harder to catch you up later, but if you have questions, let us, because if you have it, somebody else, I'm sure, is having it. So we want to get these two together. I like to just kind of make it clean, so let's subtract 2xy from both sides. And then now, I don't like having this 1 times x squared, so let's just put this as x squared dy dx minus 2y dy dx is now equal to negative 2xy. What do we do with that dy dx? Because there's two of them. How do we make them so there's only one dy dx? Factor. Again, our favorite thing. No, nobody likes factoring. I don't know. Does anyone really like factoring? I never did, but I could be wrong. Okay, so again, and that's why I like to use multiple colors. So this is a part that's going to factor sort of to the back side. That means what's left in the front side is x squared minus 2y. These guys are in a parentheses. Dy dx is factoring out. And sometimes what you might do is redistribute it, and you say, oh yeah, it's the same thing. But this is, I remember learning this, and it was like this was when lights started to go on, but I still got it wrong a lot of times because it seemed strange to do this factoring, right? Because usually we're distributing. But when we got to this point, to get dy dx by itself, what do? We just divide by whatever's in front of it. X squared minus 2y. Put a parentheses if you want. Right, those cancel. It's now the derivative of y with respect to x is negative 2xy over x squared minus 2y. And again, I guarantee you, if you've made a mistake on this, probably where it will be is that first term, the product rule. But again, this, as you practice this will also help you get down the product rule. Okay. Whenever we got two things multiplied, remember we're going to end up with two terms, not one. So one term becomes two terms. It's always got to happen with the product rule. Okay? And what you start to see is because we've got a factor and divide, our answers typically will also be fractions. Be something divided by the whole thing of however many dy dx's we had.
So the product rule comes into play when what?
When you're multiplying two functions. And so in this case,
So on number 3 right there, just by looking at that x, y, 4,
yeah, exactly, you got it. Anytime we're multiplying two different terms, two different variables, two things, yeah, so on 4, that's going to be involved. Well, on 3, you're going to have a product rule here. On 4, you're going to have two product rules because you've got two terms that have multiplication, right? So you're going to get good at the product rule, whether you like it or not. You're going to get some practice with the product rule. Questions? Is that any part? Because I'm going to erase it and we're going to move on. We're going to see if we can find one that's. We can come back to a couple of these. Okay. Going once, going twice. Gone. I want to come down and see. Okay. Yeah. Since we're relatively new using exponentials, we did it, what, just last week? Or did we just do that Tuesday or Monday, didn't we? Monday. So really new. How about 5 or 6? Do I have a, which one would you like to do? We could do them both, but 5?
Yeah.
5 sounds good. It's a little bit more complicated. It's actually, on these, if there's a little bit more to them, they actually are easier to understand. So taking the derivative of x squared is easier to see than taking the derivative of x because it just becomes 1. Okay, so let's, oh, these are going to be some, so number 6 is what we're going to focus on. X squared e to the y minus y to the fourth equals e to the x. Okay so far? I just rewrote it. That first term, x squared e to the y, what rule are we going to have to use with that? Product rule. It's harder to see. E is a number, but it's to the y power, so it is a function. And this is where it gets funky. Remember, e to the x or e to the y is its own derivative, so it gets to be really hard to see when we took its derivative and when we didn't. Okay, so I'm going to emphasize I'm on this first term. I'm going to take the derivative of x squared. Derivative of x squared is 2x. Okay. And then e to the y just stays. I don't take its derivative, right? Product rules, you take the derivative of the first times the second one, sort of unchanged. We didn't take its derivative yet. And then we're going to add, it's the first one unchanged, so x squared stays x squared. Now we're going to take the derivative of e to the y. What is the derivative of e to the y? E to the y. It's its own derivative. But how do we know we took its derivative? Because we have to say this time we took its derivative so that we get a dy dx. So notice the first term has an e to the y, but that's not its derivative. The second term has an e to the y, which is its derivative, and we have that marker that says we took its derivative, dy dx. Does that make sense? A little? Okay. So that's just that first term. Remember, that first term becomes two terms. It's like if we FOIL, right, we get a lot of different terms. So that's just the first part. Questions? Okay, because you're going to basically get the same thing, but then we need to take the derivative of y to the fourth. Maybe I'll change colors to, what's the derivative of y to the fourth? The 4 comes down. We subtract 1 from the exponent, it becomes y to the third. Since we took the derivative of y, we put dy dx. We've got an equal sign here. Now we've got e to the x on the other side. We have to take its derivative. It's not just a constant, is it? It's e to the x. What's the derivative of e to the x? It's its own derivative, e to the x. You see how it's simple, but it's hard because it doesn't feel like we did anything to it, but we did. It's its own derivative. E to the x, the derivative of e to the x is e to the x. You might want to put dx dx if you want. We could do that just to signify, yeah, I did take its derivative, but even that's going to become 1. Okay? So again, we're not quite done yet. But we're done with the calculus. We're done taking derivatives. Now it's about algebra to get the dy dx factored out by itself, everything else to the other side. Okay? And so, again, what I like to do first is any term on the left side that doesn't have a dy dx, let's get it over to the other side. Because as you'll see, as you do a few of these, that's going to be in the numerator, right? We're going to factor the dy dx out, and then we're going to divide. All that stuff's going to be in the denominator. You'll just get to see. Some of you will get really good at this, and you'll almost just be able to see it as you're doing it. You'll get better than I am at it, so that's fine. I'm not a mathematician. I'm just a guy who teaches math. I'm a math educator. Okay, so far we've got this x squared e to the y, right, because this becomes 0, dy dx minus 4y cubed dy dx. Now, some of you, you may want to do the factoring at this stage, so you save yourself having to write it. I've done that before, and I find I lose people if I don't do it a little bit slower. So notice I just copied this stuff down, and then on the other side, dx is 1, so I have e to the x minus 2x e to the y. I now factor my, and again I like to use colors, dy dx, here's one, here's the other. Those are going to factor to the backside, which means what's left behind is x squared e to the y minus 4y cubed equal to e to the x minus 2x e to the y. And the last step is a division. So we're going to divide, and this whole thing ends up over here. X squared e to the y minus 4y cubed. It got canceled, and that's our answer. Okay. And again, the hardest part is focusing and getting through each step and writing things down correctly. My problem is when I copy things down, I can make copy errors. It's easy to do. Make sure you have, and like, I'm all over the place. I'm not as organized as some of you guys. Some of the way you work is awesome. Give yourself room. That's one of the things when I was struggling with math, I realized I was trying to put my scratch paper all over the place. As I organized, that's what my dyslexic professor taught me. Well, he didn't teach him very good, but organize and go down. You'll do better. Okay, take your time. But the answers are always, for these ones, typically, since we're going to have two dy dx's, there's that last step. We end up with this fraction. So you kind of see there's almost this ebb and flow. They almost become fun. Almost. Not quite, but okay. And again, they're going to help you build that ability to take derivatives. They're going to help you build that quotient, the product rule. This one could help with the quotient rule, but what would you suggest doing with this e to the x over y squared? Should we use we could use the quotient rule, right? What else could we do? Couldn't we make that y to the negative 2 and move it up and then just use the product rule? It's easier. Quotient rule will work too, but it's cumbersome. Use the product rule, so move the y up and then you'll be fine. Okay. Let me just, oh, cool, everything moves up. Down here, you'll have a few questions where after you've taken the derivative, they want a value. Notice they give you both an x and a y because our answers have both x and y's in it, right? dy dx. So to get that rate, we need a point, not just x equals negative 1. We need to know what y is. We plug those in, and so we can get the values. We can get the actual slope. And notice on this one, the expression of the slope of the tangent line in terms of x and y, this isn't something you can plug in to your TI-84 now. I showed you a method where you can plug the function in and you can get the tangent line. It's not going to work here. You're going to need to take its derivative, plug in the values, because the derivative is what? Slope. Maybe should we do one of these? Okay. Which one? 8 or 9? Oh. You would have to choose the harder one, right? Okay. So actually, as I read through this, the first question A is what is the expression for the slope of the tangent line? So that's going to be the derivative. We'll get that. The second one is what is the actual equation of the tangent line. So we'll do both parts. Okay. See if I have enough room here. So we're going to start off with 2x squared minus y squared equals xy. And realize this is going to be the answer for the first part because none of that is in red. Only the points will change. So when you pull up your homework, you may be given a different point. So when I take the derivative of 2x squared, what do I get? 4x. 4x to the first, right? Because the 2 comes down, multiplies, and subtract 1. Okay, good. I take the derivative of a y squared. Negative 2y to the first, dy dx. Got my equal sign. So far it's going pretty good, right? xy. Yes, sir.
We find the derivative for x, y. X of
Product rule. You got it. Yeah. So now this side is actually going to be the harder one. We've got to use the product rule here. Okay. So let me get this out of the way. Derivative of x, right? So this is two things, x, y. Remember, it's going to become two terms. The first term, we take the derivative of x, which is 1, because it's 1x. That's its derivative. We didn't take the derivative of y, but it just multiplies. So you might just write y, but I write that 1 to indicate I did take the derivative of x. Okay? And it needs to be there. I'm doing the product rule. The second term, we do a plus, and what's in the second? Well, the x tags along for the ride, not changing. We take the derivative of y, which is 1 dy dx. And that's done. So we've got our derivative on the left side, the right side. This one's a little more complicated because we've got a dy dx on each side, so we got to get them together. So how about, since this is negative, what if we added 2y dy dx to both sides? And if we, since this y doesn't have a dy dx, if we subtracted y from both sides here. So I know we're doing two things at once, but let me know if it's, let's see. So on this side, we end up with 4x minus y. On the other side, this canceled. This is going to cancel. We end up with x dy dx plus 2y dy dx. We okay so far? It's algebra. Just getting everything with the dy dx to the same side. You could go either way. Getting everything that doesn't have a dy dx to the other side. And then now what do we do with this right side with these dy dx's? Factor. Okay, so that's a factor, factor, factor. And again, it's kind of the hardest thing, at least for me, it was the hardest thing to see. I don't know how many times my professor had to tell me that. Like, oh yeah, that's what we do. We're going to factor this out, and that's going to give us our slope, right? So we're going to get dy dx factored out. What's left behind? X plus 2y equals 4x minus y. We divide by this x plus 2y. So it cancels. So we get that dy dx is equal to 4x minus y over x plus 2y. That is the answer that they want the expression for the slope. That is the rate of change, right? That is the slope of the tangent line at any given point. Kind of like on the exam, they wanted the derivative at t. They wanted the velocity or something at t, right? So we put that in here, 4x minus y divided by x plus 2y. Okay, so that's the first part. The derivative is also the slope of the tangent line. Remember, we have these multiple meanings. Any questions on any of this part? Because actually I think I'm going to delete it so that we can then do the tangent line, which shouldn't be too bad. So got plenty of time. Okay, so I'm going to delete it, and then we're going to use this information. So that's, again, calculus is all done. To get the equation of the tangent line, remember the tangent line is going to be y equals mx plus b at the indicated point. So we need the slope at the point, in this case, negative 1, 2. So we take our expression for the slope, 4x minus y over x plus 2, and we plug in the point. So we're going to get the slope is 4 minus y. Let me put these numbers in red. The x is negative 1, 4x, so negative 1 there. The y is 2 over x plus 2y. I'll fill that. X is negative 1, y is 2, and now it's just math. 4 times negative 1 is negative 4, minus 2. 2 times 2 is 4, so that's a plus 4. Negative 4 and negative 2 is negative 6. Negative 1 plus 4 is positive 3. So our slope is negative 2. That's our slope. So then we know that we have an equation y equals negative 2x plus b. Right, just from, because that's a general form. We need now to know what that y-intercept is. How can we find it? Well, you could use the point slope formula if that's your deal. I never like to remember any more than I need to. So I also remember that we've got an x here, negative 1, and a y of 2. So if we plug that in, y is 2 when x is negative 1 plus b. We will solve for b, and then we'll have our linear equation. So negative 2 times negative 1 is positive 2. Subtract 2 from both sides, and you get that b is equal to 0. So our linear equation is just y equals negative 2x plus 0 if you want, but you don't have to put that in there. The y-intercept is 0. Okay. Yes, sir.
Where do you get a 2, or replacing the y with a 2?
Because that was the point that they gave us up here. So we're, yeah, sorry about that. So going back to the point. So we needed that point. We had to plug it into the slope formula to get the slope. It's not, well, the expression for the slope. It's not the y1 minus y2 thing. And then we get y equals negative 2x, which, we found the slope was negative 2. Y equals 2x, negative 2x plus b. This is just algebra. And then what I always do is I take the x value and the y value, I plug it in here, solve for b. How many of you use the point slope formula? Anybody? Maybe? Well, you could look it up, but this is the way I find much easier, point slope. But if you're using the point slope, you might find that to be easier. So there's more than one way to do it. But this is the equation of the line. I'm just going to put a plus 0 so that you know that it's, it's y equals mx plus b. But you don't need to have that there. But typically when you want the equation of the line, it's always going to be y equals mx plus b. Okay, and remember that's the line that's tangent. It's not part of the function anymore, it's just a tangent line. So that's the other thing is we got the function up there, we took its derivative, that's all connected. This is just a line that's tangent. So it's going to be a little different. Okay, how's that? Think you've got enough to, let's see if there's anything else. So slope of the tangent line, equation of the tangent line. This one, you're going to find the derivative at a particular value. Now, notice this one, we do know that x equals 6, but they don't tell us what y is. How could we figure that out? One more thing that we need to know. They're going to have us, I won't go through the whole derivative part, but if we know that x is 6, how could we figure out what y is? We have to come back to the original, right? We plug in 6 for x, so you'll get 6y minus 3,000 equals y. You need to now solve for y, subtract y from both sides. (5y) add 3,000 to the other side equals 3,000 divide by 5. Y is going to be equal to 600. I think 3,000 divided by 500, 600. 30 divided by 5 is 6, should be 2 zeros. So they didn't give you 2 points here, but you need the 2 points because you're going to have a derivative that has both an x and a y, and you'll get stuck here. You say, well, how do I get the y? You have to plug it. And they don't show you that probably anywhere in the textbook. They just you got to figure it out. But plug it into the original function, you can then solve. And so really, they should have given us the point 600, because that's what we're going to be using. But we had to be innovative and figure, okay, they gave me this, I go back to the original, I can figure out why. Okay, so on this one, that's what you're going to use. You go through like we've done, again, you've got a product rule, find the derivative, and then plug in both the 6 and the 600. 6 for x, 600 for y. You'll get a numerical value, you'll get the derivative. And then remember, this is just, you're going to copy, when the price is set at $6, that's what that is. The demand is this. Again, here, they give us just the x. But when we take the derivative, they want a particular value. It's going to have a y in there. We need to know what y is. So we plug in x here. It's going to be a little complicated because y is going to be a quadratic, but solve for y. Okay. You'll be able to do that. And that's it. That's it. The last one's a little bit of a challenge, but not too much. Once you have a quadratic, you can graph it, find the x-intercepts, and we're all good. Okay, have a wonderful weekend. Remember to breathe. I sometimes forget myself to breathe, and then you're going to pass out. Yes, sir. Oh, sure.